Namaste students. How are you? Okay, fine. I came here to explain an important topic for you. That is capacitor. Do you know what is capacitor? Capacitor is a device which has capacity to store energy or charge. In your fans, motors and any other electric devices, capacitors are used for their proper function. Okay? Now you write the definition of capacitor. Okay? Look here. Capacitor. Okay? A capacitor is an arrangement of two conductors separated by an insulating medium that is used to store electric charge and electric energy. Okay? Capacitor is a device which is used to store either electric charge or electric energy. I also find the expression of energy stored in the capacitor. Okay, later. In capacitor, capacitance is presented. Okay. What is capacitance? Capacitance, the charge required to be supplied to either of the conductors of the two capacitors so as to increase the potential difference between them by unit amount. Again we repeat, the charge required to supply of either of the conductor of the capacitor so as to increase the potential difference between them by unit amount. Okay, that implies capacitance is equal to charge on either conductor upon PD, that means potential difference between the conductors. Commonly capacitance is denoted by C. Therefore C is equal to Q upon V. Here Q is equal to charge on either conductor and V is equal to potential difference. Okay? This is the definition of capacitor and capacitance. Actually, capacitor has different type of shapes like spherical capacitor, parallel plate capacitor, cylindrical capacitor. Different type of capacitor is possible in the universe, but here we explain only parallel plate capacitor, because parallel plate capacitor is important between them. Okay? Capacitor is a shell-like device. You can see in your electric fans. Okay? It is used to increase the rotation per minute of the fans. Okay? The symbol of capacitor approx equal to the symbol of shell, because it is the cell-like device. Like the symbol of capacitor, symbol these are the two plates of the capacitor. Okay, this is the symbol of capacitor. It is also represented as so what is the difference between them? First and this is the second. This is the capacitor with fixed capacitance, okay. This is the capacitor with variable capacitance, okay. That means the capacitance of this capacitor is never changed, while the capacitance of this capacitor is changed, okay. You can see this is the symbol of shell. This is the symbol of shell. But here the length of first is larger than length of the second. Here the length or height of the both plates are same, okay. When we provide some charge on the first plate of the capacitor, then same amount of charge is induced on its other plate, but in opposite form, okay. Like here a capacitor, okay, plus Q charge is given to its first plate, then minus Q charge is induced on its second plate. Amount of charge is same, that means magnitude is same, but sign is opposite, okay. From experiment it is found that Q varies as V, okay. Q varies as V. That means the amount of charge given to the plate of capacitor directly proportional to the potential difference produced between the plates of the capacitor, okay. That implies Q is equal to C into V, where C is a constant and known as capacitance of the capacitor and known as capacitance of the capacitor. Okay, that implies C is equal to Q upon V. This is the mathematical form of the capacitance of the capacitor. Here units of capacitor, units of capacitance, okay. Since you know that C is equal to Q upon V. C is equal to Q upon V. Okay. Here Q is charge and V is potential difference, PD. Okay. Charge is measured. Speak out. Charge is measured. Charge is measured in Coulomb, while potential difference is measured in volt. That means Coulomb per volt. Okay, which is called Farad. Farad. F. Its symbol is capital F. This indicates that the SI unit of capacitance is Coulomb per volt or Farad. But Farad is the larger unit of the capacitance. Its practical unit is millifarad or microfarad. Its a smaller unit is millifarad or microfarad. 1 mF is equal to 10 to the power minus 3F. Okay, and 1 mu F is equal to 10 to the power minus 6F. Millifarad and mu F, that means microfarad. Okay, so commonly capacitance is measured in millifarad or microfarad. Okay, now I am going to discuss about parallel plate capacitor. Parallel plate capacitor. Parallel plate capacitor is a type of EG capacitor whose plates are parallel to each other and separated by a small distance. It is common type of capacitor and commonly used in the formation of different type of electronic devices. Okay, like it is used in fans, electric motors, and any other devices. Okay, here question is arised: what is the value of capacitance produced by a capacitor? Okay, here capacitor means parallel plate capacitor. Capacitor means parallel plate capacitor. Your topic is expression of capacitance in parallel plate capacitor. Expression of capacitance in parallel plate capacitor. Okay, expression of capacitance in parallel plate capacitor. Okay, expression of capacitance in parallel plate capacitor. Here this is a parallel plate capacitor. Okay, because its plates are parallel to each other. Initially, the plates of capacitor are neutral. That means no charge. Okay, when plus Q charge is given, plus Q charge is given to its plate. First plate, okay, then minus Q charge is induced on its other plate. The distance between the plates of the parallel plate capacitor is D. Okay. Here, electric field is produced by both plates, either outer region or inner region. In outer region, the electric field produced outer region of the both plates are cancelled to each other because both have same magnitude but opposite direction. Here electric field is produced. Okay. That implies electric field produced by the capacitor plates of the capacitor E is equal to sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught. This is the electric field produced by the first plate. This is the electric field produced by the second plate in the inner region. Okay. This is the application of Gauss's theorem. Okay. Here 2 epsilon naught sigma upon sigma, that means 2 sigma upon 2 epsilon naught, 2 cancel, therefore E is equal to sigma upon epsilon naught. Okay. If V be the potential difference, if V be the potential difference of the capacitor, then V is equal to E into D. According to the definition of electric field, the potential difference acting per unit length is called electric field. V is equal to ED. That implies V is equal to, this is the equation first, sigma upon epsilon naught into D. Okay. Here C be the capacitance, of the capacitor, okay, of the capacitor, then C is equal to Q upon V from the formula of capacitance. Okay. That implies C is equal to Q. Here V is equal to sigma upon epsilon naught into D, but Q is equal to, Q is equal to sigma into A upon epsilon naught into D. Okay. sigma A upon sigma upon epsilon naught into D. Okay, this sigma cancelled to this sigma, and here C is equal to here C is equal to C is equal to epsilon naught A upon D. This is the expression of parallel capacitance of parallel plate capacitor. C is equal to epsilon naught A upon D. Okay? In next class, I will teach you energy stored in capacitor or combination of capacitors. Till, thank you. Jai Hind.